This is DIY home hydroponic system. It's compact, it grows lettuce and costs pennies. Let me show you how to make your own. It's similar to a bucket with holes in the lid, known as Kratky method. Proposed by Dr. Bernard Kratky in 2009, it's home hydroponics favorite. It's delightfully simple with no pumps needed, but still big and unwieldy and requires actually buying said bucket and cutting holes in thick plastic and storing it in winter if you are a summer-only gardener. Bottles though, bottles were my real gateway drug. You already have them. They're small and modular. They don't work that well without 3D printed parts, so of course feel irresistible to any maker. Another thing that's more convenient about bottles is the nutrient solution mixing process. I have this decommissioned 5-liter pot, and it's good for 2.5 bottles. Of course, you don't wait for them to go dry before refilling, so one pot might be fine to refill all your bottles. With 25-liter container though, it's full of roots, so you'll end mixing 5-liter batches several times in a row. I also discovered that while you can lift the lid with all the growth, it's two-hand job, so who's pouring? The next season I'm going to keep one of the holes free and print a plug for it. The idea is by no means new, and I learned it from this video by Hoocho. But how do we go from a tiny seed to a lovely green plant? There are indeed many options, each step of the way. But I won't bother you with all of them, or even all that I have tried. I call this optimally easy way. Start with bottles. You'll want bigger ones. 2 liters work well, 1 liter still works, and it's better if they have wide openings. The link for a few common sizes is in the description. We'll get back to the insert designs later, but for now just make sure they fit. And source cotton wool or rock wool if you have it, to loosely fill each print. Keep them above your water tray. I suppose I should have mentioned that earlier. It's a standard propagation tray from a store, but of course you can print it. Fill it with water. Wet the medium in the seeds. Cover with clear plastic for the first day or two, and keep an eye on it. Eventually, you should have tiny seedlings, and that's when you can choose to switch to a nutrient solution. You'll have to talk about them anyway, so why not now? I use Tetra Aquatica Tevard Grow. They've changed names a few times. It has a convenient table, so calculate how much you need for your water amount and the growing stage. There is something to say about pH, but more on that later. More waiting and your lettuce, or whatever it is, will have its roots poking out of the bottom opening, ready for planting. Compared to how I did it the first time, it's an extremely easy process. You already know how to mix solutions, right? Just recalculate for the new growing stage. Plants love light, but so does algae, and that's why we try to darken the bottles. You can get fancy with spray painting, but I just wrap them in foil and hope for the best. And through the power of editing, you can see it has worked fine. Lighting. I happen to have an open balcony and use sunlight. This way you don't have to worry about the airflow either. The beauty of Kratky is in set it and forget it, but of course, at some point you'll have to add nutrient solution. That happens sooner than later with bottle plants growing outside in direct sun. So, better go print a funnel. I designed this one. It's a solid body that prints in valve mode. With lines a bit wider, it's plenty watertight for our needs. For the insert model itself, I had a few revisions. The purple one is my first. You can see it had a large watering hole, and the channel ran down into the root opening, taking up quite a bit of space. Later, I made the top of the watering channel smaller, since it only needed to fit the tip of my funnel. Much later, I realized I could add a side hole for watering, leaving the bottom opening just for roots and not taking up much space in the insert. The watering process is much faster this way. The walls can be thinner, since you don't really need much material. I made a few for different bottle sizes, because I had at least 3. Most of them are printed in PETG, and some are 2 growing seasons old. PETG works well and is more moldable, so it's perfect for that interference fit we want. I briefly used PLA for inserts and for clipping them in for security, and they crumbled and deformed in the sun. Thankfully, there is a finite number of standard throat sizes, so I have 4 different ones and called it a day. 2 of them are for the same opening sizes but in 2 different materials. One is softer and the other is stiffer, so for a good fit you'd need slightly differently sized prints. Such is life. Now the scary words of EC and pH. Electric conductivity is a roundabout way to measure how concentrated your solution is. While I have this meter, and it seems to be reliable and low maintenance, beginner plants I grow are fine with recommended amounts from the table. In fact, if you look at the recommended numbers for different plants, you'll see that tomatoes like it very different from lettuce. But does this look like failing to thrive to you? Don't bother about EC just yet. pH, though, was more of a struggle. This meter came without instructions, but apparently you have to keep the probe, this glass bit here, constantly wet with potassium fluoride solution, or it stops working. If it's high, you add some citric acid, mix and remeasure. Repeat until satisfactory, and be diligent with your note-taking. Now, let's grow some lettuce. The next video is going to be less leafy, maybe.